There we go. Recording in progress. Let's get started with today's lesson. Today is input-output. I know that because that's what I did this morning and trying to keep everything coordinated. So it should be 4, user interaction. And I need a secondary copy so that I can demonstrate stuff. I need to fix that. It's supposed to ask me for my password. Guess it would help to be in the correct class, though. Go to our friend Untitled 1, and that will come in handy because I don't have to cut and paste as much. All right, good afternoon. So today we're going to examine essentially the input function, which is a tool that lets us instruct the computer screen to ask for input and capture it from an input device, which for all practical purposes will be our keyboard. There are other input devices when you get fancy, but we're not there yet. So the key tools are going to be the input function, and then the print function you've already played with, but we're going to look at some different ways to use it. So our objectives for today are for you to develop an awareness of interactive inputs, implement said inputs to generalize your solution tools, develop awareness of output formatting to improve readability and implement formatting. Useful programs take input, generate output. So I guess by argument you could say that up to this point nothing we've done is useful. It is, but not in the usual sense. We're dealing with ways to interact with our human user, and we do that through what's called an interface. And there are at least 2 kinds of interfaces. One's called a command line interface. I will demonstrate that in a second. Let me go ahead and bring up a terminal window. And so there's my command line interface that's talking to this laptop computer. I happen to have something installed, so it's going to talk to you as soon as I hit return. It's going to go, "Hello, class." But it's going to sound like Stephen Hawking in Big Bang Theory.
Hello, class.
As warned. So that is a command line interface. We can do stuff like list contents of a directory, all sorts of interactions. In the olden days, when I was a student, that was all there was. The graphical stuff didn't come for a few years, and I'm not that old. It just graphical user interfaces are comparatively new. So 78, 80, late 80s, early 90s was when GUIs started to become really prevalent. And then there was this graphical user interface acronym is GUI because it's what you get on your fingers and you can't wash off. Windows, the first Windows 3 point something was the first GUI, and we've never been able to wash ourselves of it since. Actually, it wasn't. It was by Palo Alto Research Corporation, working for Xerox. So those are the 2 interfaces that you'll primarily deal with. There are other ones. I know some of you have talked about doing edge networks and Raspberry Pis. So what kind of interfaces are there in that? You going to share, Elizabeth, or no? No. Okay. So there are other interfaces. Any of you have dabbled with that. That whole set of pins on it has at least 4 different kinds of interfaces that get between for lack of the computer part and the pin. But we're not going to mess with that in this class because we're not allowed to. You have to take other classes for that. That's how the university generates profit continues to exist. We also interact with files, and they come from some different sources. Actually, I don't know what these last 3 bullet items are here for. I think that's a mistake in my notes. So up to this point, we have explicitly specified input for variables. So we did something like variable name equals some value. Now let's leverage the intrinsic functions that lets us make that somewhat interactive. So instead of having to be able to go into the script, essentially modify code to rerun it, we'll let the script ask us for information, and then we can deploy it and sit at home and drink mint juleps while the money flows in. Oh, that got everybody's attention. So we're going to look at the input function. So the name of the function is input. I don't know why they picked that name, but so be it. I do know why. I mean, it's an obvious name for an input function. And it can take up to, it can accept a single parameter or argument, which is shown in the parentheses. And here I'm using the placeholder prompt. And prompt, it assumes, will be a string, either a string literal or a string variable. And it will print the prompt to the command line. And then it waits for input. It literally waits for a carriage return and a line feed, or the new line symbol and return symbol, which we achieve by pressing the any key. The any key is the one that's labeled enter or return on most computers. Why do you think it's called the any key? Perhaps you've played with computers in the past and it always tells you to press any key to continue. So today, the return key is the any key. And hopefully that general isn't in there being at fault and protecting everything. So we're going to actually just execute this script right here, but we'll do it in a different window so we can actually see it execute. But let's see what we're asking it to do. It's going to prompt us with the question, what is my name? And I'm going to answer that. I'm going to give it a name. And then it's going to print what I put back. Now we can practice that third language that everybody claimed to have, which was profanity. So keeping that in mind, let's go ahead and execute it. Everything below this box, just ignore it. Don't look behind the green curtain. So what do you want to give as your name? I'm thinking something profanity, right? Although this is being recorded, so I would regret that.
Just look like 4 stars.
How about fire truck? Okay, fire truck you. Sure enough, it regurgitates our name. Oh boy, we're programmers now. We're going to get through this class after all. Well, obviously there's more to it than that, but we got to start somewhere. So what happened is the input method sent the string, what is your name, question mark, to an input-output device, in our case the screen, which was incorporated interior to the Jupyter notebook, and so made that pretty box around it. I have no idea where the script is on my computer, otherwise I could run it with command line interface and it would look different. Oh, I know how to do that, but we'll get to that in a minute. And then waited for us to reply. We replied with fire truck you. And then once I pressed the any key, also known as the return key for those of you at home without a calculator, it captured that character stream and then regurgitated it back to me. Okay, you're not the most high-level programming, but it's what I assure you that Ukrainian hackers are trying to do right now. The next statement, the print statement, just printed the contents of my name back. And actually from that exceedingly simple structure, we can create all sorts of useful input and output. As a matter of good practice, you should get in the habit of explicitly typing your input variables. So for example, we'll do my name, we'll have my name equals string, what is your name, and we will print my name and then we'll type it. So here's what we did initially. We will force whatever we type into a string, and then to prove it, we will, that should work. I'm getting a little sloppy here. I'm depending on the Jupyter Notebook kernel to handle some of my input-output for me. So we're going to ask what my name is. It's going to force it to string. We'll print it back, and then we'll see what type of variable my name is. So we're just going to shorten our name to fire truck. It indeed gave us a fire truck back, and it was a string. If we play the same game but with a different variable called my age, we'll tell it that we're 122 years old, and it returns back the 122. So when I hit the type function, it's going to tell me that that type is integer. How did it know to take the 122 input and make it into an integer? Because I told it to. Excellent. If we don't do that, we'll stay the same age, but now when we type it, it's a string. So use typecasting, which was the subject of last time, to help control what you're having your scripts actually do. See more examples. Oh, they're already set up, so I don't have to cut and paste. So here's another one. Let me get it back to its original setup in the notes. Okay, so that's, I think, what it says in the notes. It says, please enter a value. So somebody pick a value.
7.
7 it is. And it regurgitated 7 back and put single quotes around it, so we know that 7 is a string. We can repeat that, only this time we'll have it tell us what type 7 is. It tells us it's a string. We also can run the input without a prompt. Doesn't take too much of a genius to figure out. That's really not terribly helpful because it's expecting input, but we don't know what to give it. And fortunately, I hit the any key. I don't know what that is in Rambosian, but that's a hard word to say. We can play some other games. So I'll do the same thing again. So that's a really long string. And the one that says print the hexadecimal value of the ID of the variable, that's going to tell us where it is in the memory stack on my computer. So KJFGLHG, blah, blah, blah. It starts at memory location 0x7F01605AA1B0. And you can use a hexadecimal to binary or hexadecimal to find out what that memory address is. We're going to play that game again, probably not today, but later on in the near future, where we can demonstrate using memory addresses that the numeral 7 type converted into an integer becomes identical to the integer 7. It's really weird and goofy. No, Goofy's a fictional character. It can't be Goofy. We also can construct the prompt as just a string variable which has some utility. Let's see, let's go just between that and Taco Bell. We also can build the prompt as a string variable, so enter a value, but we don't want that. Enter your, there you go. Okay, so choices: food, color, TV show, movie. What do you want to make it? Movie it is. Okay, so we're now defining the string variable. Enter your favorite movie, and when it hits us with a prompt, what do you think it's going to type? You type enter your favorite movie, and then we have to answer it. So it's asking for our favorite movie. So what's your favorite movie? I'm sure it's RoboCop.
Of course.
One. The most exciting 10 minutes beginning movie to watch when you're babysitting a 2-year-old baby. As far as I know, she grew up, got married, and is not too damaged, so never let me babysit her again. Outside, no, that first 10 minutes, you do not babysit. That was actually a really bad babysitting experience for me. Because chili and cheese, you don't feed that to babies. But you learn that the hard way. Okay, so there we've gone and used a string variable in place of a string literal. Now for output. Our main output tool is the print function. And actually in Python, I think that is the main output tool. And it prints values passed to it. It'll automatically convert data values into strings unless you tell it otherwise. It goes to a new line by default when it gets to the end of the input stream, the input to the function. It separates values with spaces by default, and there are optional values that can be added to set different separator and align values, and we can use formatted output using various formatting functions. So let's start from the beginning and proceed forward. So here's our print function. So if we were to put our name into a variable as Taco Bell, and our age is 66, so named because Taco Bell's first store was on Route 66, and then we print back to our screen, hello world, my name is, the contents of my name, and I am, the contents of my age, years old. We should get back, hello world, my name is Taco Bell and I'm 66 years old. We supplied five inputs to the print function. The first one was the string literal, hello world, my name is. The next one was the variable not my name, which coincidentally happened to be a string valued variable. Then the string literal, and I am, and then the variable my age, which is most likely an integer, although we didn't type specify it, and lastly the string literal years old. Here's a few more examples, and this one right here illustrates what tools you have if you want to control how it prints stuff out to either the screen or to a file. So we're setting the value to 77, and first line prints here's a message. Next one prints here is a value, and it puts the value, my value, which is 77. The next one is the useful one, or useless, depending, I guess, on your situation. It says don't go to the next line. That's the message. Ends with a period, which looks just like a decimal point. That's multi-purpose. You just can't beat that. And then comma end equals null. So what we've done with that part where it says comma end equals, I think that's null. Let's find out. Hard to tell. So there might actually be a space in there. But the normal end at the end of a print statement is escape character, lowercase n, which is a new line, which you never see. It creates a new line, and then escape character, lowercase r. Now in a Macintosh, I think you do line feed carriage return, and on Windows PC, it's carriage return line feed. So the sequencing of the hidden characters is important. Oftentimes, if I send a file from my machine that's an ordinary UTF-8 encoding to someone that has a Windows machine, my file is unreadable to them because it has the carriage return line feed in the wrong sequence. And all you do is run a string editor to flip them. Although most modern APIs manage that for you, you never notice it. But not in this class, because I use old crap. So that end equals blank essentially replaces the line feed, and all it does is insert a space. So when we run the expression, or that statement, here's what we get out. We get don't go to the next line, and then the new line in the code is print more text same line. It prints the more text same line. Now that doesn't have any special ending, so it goes on to the next line in the output to put more text new line. There is more than just this particular directive that you can put in a print statement. There's a bunch. And you have access to that bunch through the use of the miracle of the mighty internet. So let's talk just a brief bit about strings. It's a complex data type, not complex in the sense that it has a real and an imaginary portion, although it's all imaginary if you get down to it. Complex in that a string is a complicated thing. Because it has a name, the string has a name, and the string has an undetermined number of characters in it until it's created, and at the moment of creation, the sequence of characters becomes unchangeable. So once you create a string, you cannot easily make that string longer or shorter. There are ways to manipulate it, but by design, once it's created, it exists like that for its life, however short. The individual characters themselves are identified using a position indexing, and the syntax is whatever the string name is, and then whatever the position is. So here's a string, Geeks for Geeks, which is a website where a lot of this stuff is stolen, borrowed from, properly attributed. And if you imagine each of these containers holding a letter, so this container here to the left holds a G, the one next to it's holding an E, another one holding an E and K, and so on, moving from left to right. The left edge of the leftmost box is labeled 0. That box's position indicator. So that's box 0. 1 corresponds to this first E, 2 corresponds to the second E, 3 to the third E, and so on. So if we want to get the first 4 letters, we need position 0, 1, 2, and 3. And that's all because they made Python start counting at 0. Dumbasses. Pulling pieces of a string out is called slicing, and we can slice strings by specifying start indices and ending indices. Because the strings can be really long, thousands of characters, I mean, a file is just a continuous string until you tell it where to do line feeds and carriage returns. They also have implicitly provided the ability to count backwards. And so if you provide the value -1, you get the S, -2 is the K, -3 is the E, and so forth. So if we were to de-geek this string, to get rid of the first geek, we would have to slice from position 0 to 3, and pretend you could actually do this, toss that away and shove everything to the left. Now we have 4 geeks remaining. Then if we slice from position, I'm going to do the arithmetic in my head, so B, F-O-R-G. So position 3 to whatever the ending is now, you can get the second geek. So that would be how you de-geek the string. There's also the length function, which tells you how long a string is. There's a lot of other string functions. So let's just experiment with a slightly shorter string that we can keep in our head. So we'll do the string birds. So birds has 5 characters in it. The first one is B. The second one is the vowel I. The third one is R. The fourth is D. And the fifth is S. The name of this string is S. Good on time. And if we issue the print instruction and we say print string S, but only print the character whose position index is 3, BIRD. So it should print a D, and sure enough it does. If we tell it to print S with position -1, that means it goes all the way to the end and works the first one back, which happens to be an S in this case. If we ask it how long the thing is, it tells us that it's got 5 characters in it. So there's the print, the length, and there's the 5 characters. And lastly, if we ask what type it is, it tells us it's a string. So there are some useful string operations. There's concatenation, which you've seen in lab already. There's ways of testing equality or inequality of strings, and it uses a lexicographic ranking to do so. If you want to learn about lexicographic rankings, you can go to the Wikipedia link, which is built into the notes, and read here and about there. You should pass out unconscious. If you're having trouble sleeping some night, go ahead and read about lexicographic ranking. You should be out in no time. So concatenation joins 2 strings with no space between them. So for example, we have a string S1 and a string S2. S1 is the string cat, S2 is the string dog, and if we concatenate them, it looks like that, S1 plus S2. So if we print S1 plus S2, what do you expect to get as output? Cat dog, yes, twice the fun, none of the mess. If we print S1 identically equal to S3, S1 is a cat, S3 is also a cat. Sure enough, we would expect to get a true out of that. If we print S2 less than S1, which is dog is less than cat, we have to know how it sorts things. So lowercase letters are, if you think of all the letters of the alphabet going from left to right, it does the lowercase, then the uppercases, and then I think the numerals, and then special characters. I think that's how lexicographic sorting works. So lowercase c is smaller than lowercase d. So this should return a false. But uppercase d is smaller than lowercase c, so it should return a true in this case. And sure enough, we got it right. Of course, I did cheat and look ahead. And I don't necessarily know the utility of doing those lexicographic tests. Actually, I do, but not in a class of this type. There are special unprintable characters. It's kind of like unseeable things, unforgettable. You can't unsee that. It's similar to that concept. They're represented with something called an escape sequence. Not to be confused with escape sequence in action-adventure movies, which usually involves destroying police cars, shooting things up, and fire, fuels, things like that. Lately, helicopters. Been crashing a lot of helicopters in the movies. So one escape sequence for sending the new line character is \n. The tab character, not the drink, but the 5 pieces of white space between things, is \t. If you actually want to print the / character, you have to send the first one as the escape and the second one tell it that the next thing is to be treated as an ordinary old character. And quotes, \, single quote, \, double quote. Now this, when I'm labeling output in any scripts I make for my skill, I actually kind of use that more than I ever expected I would. Because trying to embed single quotes instead of double quotes and get it all to work out right is just a little bit too much trial and error. So these are all useful, but this one's actually, to me, remarkably more useful than I expected. So let's look at these escape sequences, then we'll go to the next, we'll flip over to the example where it's run. So this first one prints hello, and then it has the \n, which is going to print the word hello, and then it's going to shift to a new line. And we'll barely be able to see it when we run that. The next one, it's going to print the numeral 1. It's going to tab over whatever my default tabbing is. I think it's probably 10 spaces on this computer. And then it'll print a 2. And the tab spacing is adjustable. This last one is going to print the escape character X, which is going to make a little caret on top of the E. So we're going to get E with a little who's and what's it on top. Don't actually know the technical term for the who's and what's it. So let's go ahead and look at that. We run it. So there's hello. There's that new line right there where the cursive red baron is going. 1, 2, 3. It looks like I have 5 spaces as my default tabbing. So there's the 1, 5 white spaces, the 2, and then there's the E with a little who's and what's it on it. Anybody who knows fancy calligraphy would know what that who's and what's it's called. I don't know. You can use who's and what's it on a quiz or a test if you have to. If you can't figure out the name either.
Can you or can you?
You can. Okay. I think it's called a decorator in typesetting.
You see who's and what in the test, you know what I'm talking about.
Assuming it's appropriate to the question, yeah. Otherwise, wrong. So sometimes you have a need to print the unprintable characters, such as a tab or a new line. In that case, you're kind of forced into using the escape sequence. And here's an example with Taco Bell 66. So, hello, world, my name is, and then, whoa, hold the boat. What are these little curly brackets here? You don't know, but I'm about to tell you. So at the end of our string literal, we have a method called formatting, and we have put in little curly brackets. So those are just placeholders. What the method's going to do, it's going to take the contents of the first thing in the format and stick it in the first placeholder, contents of the second thing and stick it in the second placeholder. Let's go see that live rather than Memorex. So there's our Taco Bell thing. In this case, I put in a third placeholder. So it's okay to have more things in the format list than to have placeholders in the string literal. That will still work. But if the opposite's true, replacement space, we get the pink box of, are we going to make it box of loserness or failure or encouragement?
Failure.
Okay, you in for failure? It's a Monday. So we get this error message, replacement index 2 out of range for position arguments tuple. Okay, translating that into humanly understandable English. You wanted me to put 3 things into your string literal, but you didn't give me 3 things to put. And me being a stupid computer, don't really know what to do, so I'm just going to throw an error message at you, and I will send your credit card number to a suitable entity. So if I give it the third thing that it's looking for, it's fine. Now I have no idea how the English I am 99 years 44 old passes, but it's okay that it's nonsense right now. Lewis Carroll would be proud. There's a few other examples in the notes. This one is probably a useful example to examine live. So let's take a look at this example. We're just going to print I am 5 / single quote 9 / double quote tall. So if you know the symbology of 5 feet 9 inches, feet is often represented with a single, I guess that's a quote marker, and inches is a double quote marker. And we're using the escape character to instruct the kernel that the first thing after that escape character is to be treated as just another character. And same here, and it knows that it just wants us to put the quotes in the literal, and we get it to look right. If we didn't have that, I'm going to go ahead and get my pink screen of loserness. Let's see what's going to happen. Let's try to predict the output. Although the editor is actually giving us a pretty good hint already without even running it. We have the literal, I am 5, single quote, 9. It finds that second double quote, so that's the string literal. I don't think it's going to know what to do with a tall, but it might be smart enough to figure something out. It says that we are invalid. If we do the reasonably obvious thing, okay, that ought to fix things. In this case, it did. If we really mess with it, put another single quote here, that really starts confusing the issue. So I would suggest use the escape character if you have a need to put single and double quotes in your output. Shoot, how was that? Good, it's still in the buffer. There's also a way to force raw strings. You can precede your literal with the letter R for raw, and then it will interpret everything between the delimiters as a character. Why you'd want to do that in this particular, this is just an example to show you the effect of that. So instead of tabbing, the raw forces things into a complete literal. Now slicing a string. You need the, think of it as an expanded indexing trick. If we take a slice from a string and send it somewhere, that becomes a new string composed of characters from the initial string. So we can take a single character, we can take a substring, we can do a selection. So the starting position, ending position, and select integer numbers of it. I don't think I have any examples. We also can use empty and default values in slicing. So here is a question to which I don't know the answer because it's been a couple weeks since I typeset this. Let's go first see what's contained in S. Well, that's a fine thing. Where was our S? It was one. Oh, S is supposed to equal birds. Well, we would do the musical group, the birds, instead of the things that fly through the air. Now let's ask ourselves, what will this particular slice do? So this is going to operate on BYRDS. It's going to go to that S, which is the end of birds, -1, and then it's going to index to nowhere, and then it's going to do it in negative steps. So I'm not sure if we're going to get the pink screen of error or if it's going to do SDRYB. Oh, it does SDRYB. So that, oh man, that's a classic homework problem. Shoot, shouldn't have given that up. I mean, that's a good exam problem. How do you reverse a string? Turns out reversals are built in, but there are other ways to do it. There's much more complicated ways to do it than this way, which is you write the string out and then you count backwards, and that's how you... The reverse function is built in. It's a method that's part of the string. So anyway, we can reverse a string by this goofy syntax here. We can reverse a string using a reverse. I think it's a method. How do I find out things about Python? I type Python. How to reverse a string in Python. We'll go to W3 Schools and.
I visited this website 4 times.
Oh, this is a good website. You could teach this class from this website. Just kidding, recorder. There is a reverse function that's built in. Actually, I think it's a method. There is a reverse method. So let's see if we can find it. Well, it's not showing up here, but I know there is a reverse method because I've seen it and used it. I don't know its exact syntax. But we've seen, here's one way to do it if you actually can't find any other way. Just monkey with the indices. The various methods that come with a string are listed here. So splitting strings, removing uppercase, lowercase, testing if the string itself is numeric. You can bet that the int function and the float function immediately run those tests before it attempts to do a conversion. We have a replace and many, many more. Look them up as needed. Here are some examples of string functions. Let's see what this is doing. Upper and lower casing and doing replacement. I'll let you play with those on your own so as to get down to the percent operator. So recall earlier we used little curly brackets as the replacement placeholders where we wanted to replace things out of a list. The other alternative is the percent constructor or the percent operator. It not only identifies the replacement position, but it also gives you the ability to specify how to do the replacement. So for example, percent %s right there is saying take the first element of the percent stuff that's trailing here in the print statement, represent it in that location as a string. Take the second element and represent it as a string. And if we do that, we get hello world, my name is Taco Bell, I'm 66 years old. Or we can type convert the second one into a floating point, and it says I'm 66.000000 years old. And we can get sophisticated with the floating point specifications. We can tell it how many places after the decimal point we want it to be, and so forth. So the percent operator and percent method is really handy. The percent %f turns the tuple into a float and gives a lot of flexibility. Here's an example where we want just one decimal point. So we would have percent indicating the location, decimal point 1 telling us how many fractional portions to represent, and that we want it to be a float. And when we run that, we get hello, my name is Taco Bell, I am 66.0 years old. There's also the format method, which uses the curly brackets as the place indicators. And here is a picture. I don't even know where I stole this one from, but this is stolen because I wouldn't go to the trouble of doing that many different colors in a drawing. So we have the string to be formatted. We have the placeholders identified by the curly brackets. We have the keyword format and the value that's to be put into each placeholder. Anything outside the placeholder stays as literal text. Last part, if you have to use a really long message, the triple quote symbol instructs the kernel to attempt to word wrap it. So what it will do is it'll try to make it fit the output nicely. And nicely is defined by the programmers. Okay, we got through it. That's actually impressive. We got through it in the allocated time. So I'll see you all online in about 10 minutes. The Zoom link you get today is finally, I have it programmed as a repeating link, so you should be able to use that for the future. Were you able to get your stuff working? You did? Were you able to get all your stuff working?
Yeah.
You did?
Yeah.
Okay, cool.
I forgot to say my name when you were calling attendance. Mr. Bond. Sorry.
Well, I said your name. You forgot to
Yeah,
say
no, I
here.
forgot to say
Here.
here.
Okay, we'll do that where the rest of the world can't see.
But yeah, I'm kind of in the same
Just in
boat as
case you're an attorney trying to get me.
No.
You first.
Banda.
Banda. Oh, that's probably because that first name is Banda?
B-A-N-D-A. Nestor.
Nestor. Why can't I find it? There you are. Okay.
My last name starts with an A. It's very easy. It's Hazem Al-Hatawi.
Oh,
It starts with an A. It's usually the top.
how did you not hear it? I butchered the crap out of it when I said it.
I was 3 minutes late, so you probably butchered it in the 3 minutes that I was.
I butchered.
Well, now I'm sad. I wanted to hear that.
I butchered.
I'll hear it next.
I think I got the Hazem. I probably said Hazim.
Mm-hmm.
But Al-Watai, I probably said something like that.
It works.
He substituted something for Adam.
Yeah, I did not.
The name is because of the last name.
I did not say your name correctly.
Listen, it's the effort. That's what matters. If you put effort, I appreciate that.
Let us stop the recording.